Well, welcome back. We're talking about angles in geometry, and to remind you, we just defined angles, the object, as two rays that are connected at a common endpoint, and those angles can be measured from 0 degrees all the way to 180 degrees. 0 degrees all the way over to 180 degrees. There are larger angles, but in planar geometry, in Euclidean geometry, we only talk about the angles that are from 0 to 180 degrees, and once they go past 180 degrees, we measure the smaller side again, so it goes back down from 180 degrees back to 0. So, there are 5 classes of angles, and they're classified based on their measurements. So, the first class is the 0 angle, which, as you may guess, is because the measurement of the 0 angle is 0 degrees. Wait, you say, it's supposed to have 2 rays. How can that be? Okay, we have a ray, A, B. This is ray AB. And we have another ray. Remember, if it's an angle, it has to share a common endpoint. So, our other ray is going to be AC. Well, if the angle is 0 degrees, then C has to be somewhere on the original ray. It has to be on both rays. In other words, the rays are identical. There are 2 of them because we can name them with different points. But in a sense, there's one ray. But the angle between the one ray and itself, or the one ray and the ray that is identical to it, is 0 degrees. So, it's called the 0 angle. Zero angle. Alright. And we would name that angle A. Oh, not A. We don't name it A. A is the vertex. A always has... the vertex always has to go in the middle. Apologize for that. So, angle B, A, C is a 0 angle. We could also name it angle CAB, but the vertex goes in the middle. So if angle BAC is a 0 angle, that implies that the measurement of angle BAC equals 0. Now I can't say that angle BAC equals 0 because 0 is a number and angle BAC is an object. It has a name, angle BAC, but it doesn't have a number. Its measurement has a number. Alright. As C moves away from this original ray, we could get an angle like this. And now we have ray AB and ray AC, and they are sharing the vertex A. So we have this angle BAC. Now its measurement is greater than 0. But it's not a right angle. You're probably familiar with a right angle. Most people are at this point. But a right angle, in case not, is what makes a corner. If we make a square corner, that is a right angle. It's 90 degrees. It is halfway from 0. 90 degrees is a right angle. Halfway to the 180 degrees, so It takes a 90-degree angle and a 90-degree angle to make all 180 degrees. But this isn't that. If we have two of these, we're definitely not getting all the way to 180 degrees. So any angle that's greater than 0 degrees and less than 90 degrees is an acute angle. And it is just cute. It is so cute. It's an acute angle. It's small, and small things, as we all know, are cute. So, this is an acute angle, and the way we define it is based on its measurement. So the measurement of angle BAC is greater than 0, because if it were 0, it would be the 0 angle, but it is less than 90 degrees. If this is true, then we have an acute angle. That's the definition. Acute angles have a measurement that is less than 90 degrees and greater than 0 degrees. Alright, so I gave away the next one. Next one's a right angle. So as soon as C gets down here, so that we can put this little symbol in the corner. This symbol means perpendicular, and perpendicular lines form 4 90-degree angles. 90 degrees and 90 degrees is 180, 180, 180, and that gives us a full rotation of 360 degrees. 90 degrees times 4. 1, 2, 3, 4. So, a right angle right angle CAB, vertex in the middle, angle CAB equals 90 degrees. A right angle implies that the measurement of that angle is 90 degrees. Now, when C moves over here, we don't have a right angle anymore. We have an angle that measures more than 90 degrees. And that is called obtuse. It's an obtuse angle. The measure of angle BAC, the vertex in the middle, is greater than 90 degrees, but it must be less than 180 degrees. It has gone beyond a square angle. It is greater than 90 degrees, but we haven't reached 180 degrees, so it's an obtuse angle. And lastly, the only value left for our measurement of angle CAB is what's known as a straight angle, and that's named well too. Just like the 0 angle, it's pretty intuitive. When C is positioned so that ray AC is an opposite ray to ray AB, then point A, point C, and point B are collinear. They're all on the same line. And a line, as you know, is straight. And so we call this angle a straight angle, which means its measurement of angle CAB must equal 180 degrees. Thank you for your attention. Hope that was helpful.